I'm Anil Kumar, and in this video we will learn different techniques of finding intercepts of a function. So basically we could have x-intercepts or y-intercepts. Let us see how to find x and y intercepts for the given functions, right? So that's the question for us. So what I will do here is, first we'll take up some graph, right, and see how do we find x and y intercepts of some of our parent functions, for example, right? So, and then we will solve few algebraic equations and learn the technique. So let me sketch few functions here. A straight line. So I'll use some transformed parent functions. So if I draw a straight line here, you can see that there are two intercepts. This one is the x-intercept and that is the y-intercept. So this is what we are calling as x-intercept. And this point here is the y-intercept. So at y-intercept, x value is 0, right? X value is 0. So you could write y-intercept as 0b, and you could write x-intercept as a0. If this point is a and that point is b, correct? So that is general way of writing x and y intercepts. So let's take few more sketches and we'll see where the x and y intercepts are. So if I have a parabola, then you can see that these are the x-intercepts. Let me put x's on the x-intercept and y on the y-intercept. Is that okay? You could have exponential functions. Most of the time, exponential functions will look like this, right? They could be exponential growth or decay. In such functions, horizontal x-axis is actually a horizontal asymptote. So we only have y-intercepts in this, no x-intercepts. Similarly, you'll find that in reciprocal functions, we really do not have x and y intercepts since 1 over x is not in your domain, right? So this is 1 over x. This is, let's say, 2 to the power of x. This we could write y equals to minus x squared, let's say plus 4. I'm not giving any values, but okay. This could be with negative slope, right? So negative x plus b, let me write, okay. So these are some graphs which gives you clear idea what x-intercept is and what is y-intercept, right? Now we could have square root functions which are kind of like this. So in the square root function, as you normally see, x and y-intercept is the origin. So these are some functions. You could easily read the intercept from the graphs. Here we have none. So no x and y intercept, both are asymptotes. Do you see that? Okay. Now we'll take a few equations and see how to find intercepts. So let me take equation of line as let's say 2x plus let's say 5y equals to 10. So I've taken a very simple equation. To find x-intercept, what will I do? To find x-intercept, I'll do y equals to 0. So if I do y equals to 0, I can solve this equation. I get y 0. So I get x is equals to 10 divided by 2, which is 5. Is it okay? Think like this. Just hide this value. So you get 2x and 10. So you get this value. If you have to find the y-intercept, suppose then in that case put x equals to 0. So when you put x equals to 0, I get 5y equals to 10, or y equals to 10 divided by 5, which is 2. So you could find in this fashion x and y intercepts. Well, you could be given this equation of line in slope-intercept form also, right? So you could have equation as y equals to, let us say, 2x minus 6. Now from this form, you can see this is y-intercept, right? This is y-intercept, which is at x equals to 0. If I write x as 0, you get minus 6 as the y-intercept. As far as the x-intercept is concerned, we have to write y equals to 0, right? So we get 0 equals to 2x minus 6, and solving this, we could get, taking 6 here, x equals to 3. So x equals to 3 will make this equation 0. So the x-intercept is x equals to 3, y-intercept is y equals to minus 6. You get an idea. Okay, now let's take up some equations of this form. So if I have an equation which is, let us say, x squared minus 4 equals to 0. In that case, what do we have? Okay, let me write x squared minus 4 equals to y first. Okay, so y is x squared minus 4. To find the x-intercept, I'm equating y equals to 0, right? So my equation is y equals to x squared minus 4. To find x-intercept, I will equate y equals to 0. So what I get here is x squared minus 4 equals to 0, or x is equals to square root of 4 with plus and minus, that is plus minus 2. So we get plus minus 2 as the x-intercept. Now this is not for the graph, right? So graph portion is over. Now we are taking independent equations, correct? So let me just draw a line here. Okay. And to find the y-intercept, we just equate x as 0. So we say y equals to 0 minus 4, which is minus 4. So we get y-intercept from the equation by substituting x equals to 0, right? So the idea here is, whenever you have to find x-intercept, in that case, put y equals to 0. And if you have to find y-intercept, substitute x equals to 0, right? So that is how you find x and y-intercept. Now, let me give you some more equations. Let us say I have an exponential function, but this function has been translated down. So let us say if I have 2 to the power of x like this, and if I translate it down by 1 unit, in that case, what is going to be the x and y intercept? Let's calculate the x-intercept first. So for x-intercept, y equals to 0. So let's solve this equation for x-intercept. If I equate y equals to 0, I get 0 equals to 2 to the power of x minus 1, or 1 is equals to 2 to the power of x. Now 1 could be written as 2 to the power of 0 and 2 to the power of x. If you equate, you get x is equals to 0. So if you have this equation, in that case, it could be graphed kind of like this, and the x-intercept will be 0. So it will be kind of like this. Do you see that? Okay. Move this equation 1 unit down, you get x-intercept of 0. And how about the y-intercept? To find y-intercept in this case, what will happen? Substitute x equals to 0. So you get y equals to 2 to the power of 0 minus 1. Anything to the power of 0 is 1. 1 minus 1, which is 0. So as you can say, 0 origin is both x and y intercept for the given equation, right? We saw that for 1 over x, we may not have any x and y intercept. But if I transform this equation and write this in a different form, let us say y equals to 2x plus 1 divided by 3x minus 6. In that case, this equation will have both x and y intercept. Let us see how. So to find x-intercept, we'll equate y equals to 0. So if I write y 0, then the numerator should be 0, right? So that means 2x plus 1 equals to 0, or x is equals to minus 1 divided by 2. So that becomes your x-intercept. How will you find the y-intercept? To find y-intercept, we'll equate x equals to 0. So if I write x 0 here, I get y equals to 0 plus 1 over 0 minus 6, or minus 1 over 6. So in that case, my y-intercept will be at minus 1 over 6. You see that? So that is how you could find x and y intercepts from the equations. What you need to do is equate x equals to 0 to find y-intercept, y equals to 0 to find x-intercept, right? So I hope that makes sense. Now here, for a square root function, you could have y equals to, so if I translate this function, let us say 1 unit towards the left side, and then I can say square root of x minus 1, that is 1 unit towards the left side. In that case, you can see that the function will be kind of like this. Now how do I find x and y intercept for this function? clearly x-intercept is when y equals to 0, right? So if I write y equals to 0, I could solve this equation as 0 equals to square root of x minus 1, and that gives me x equals to 1, right? So y-intercept is this position, which is at 1. To find the x-intercept, okay, I'm sorry. When I put y equals to 0, I got all this. Square root equals to 0. So x equals to 1 is my x-intercepts. Actually, I wrote it, I showed a wrong diagram here. For this particular diagram, the equation should have been plus here, right? So, and when you solve for this, okay, so let me write this. 1 plus x equals to 0 and x equals to minus 1, right? So this minus 1 becomes the x-intercept. Because I drew like this, let me change the function. Okay, so when you work for square root of x plus 1 as your function, to find the x-intercept, equate y to 0. In that case, 0 equals to square root of x plus 1. Solving, we could square both sides. So 1 plus x is 0, or x equals to minus 1. So at minus 1, we get the x-intercept. To find y-intercept, what will you do? You will equate x equals to 0, right? So if I write x equals to 0 here, I get y equals to square root of 0 plus 1, which is 1. So that point 1 is your y-intercept, right? So that is how you could actually find x and y-intercepts when you are given graph or when you are given equations. So we have taken a few very simple examples just to get you an idea of how we can find these x and y-intercepts, right? Now here we took an example of x squared minus 4. So that graph basically will be kind of like this, right? So let me draw this graph here. And the points which we are talking about are these. So those are the x points which are at plus minus 2, right? This is minus 2 plus 2. And the y-intercept of minus 4 is right there, right?